Students, your science teacher Mukesh sir is with you here in this today this video, and today I will explain two topics from the chapter, that is the part of the science book of physics, and the second chapter, that is Newton's laws of motion. I am saying the second chapter means from the physics portion, that is first one is motion and the second one chapter is the laws, force and laws of motion. Here you can see the name, force and laws of motion. Okay, and today the topic I am going to explain, that is momentum. Momentum. What is a momentum? Students, I have these two objects. These two objects are in my hand, you can see, and these two objects are having different mass. This one object is lighter in comparison of this one. Okay, so what is the momentum? Let us see. Okay, so I am going to define the definition. You can see somehow property of moving body by the virtue of both mass and velocity. Property of moving body by the virtue of both mass and velocity means the momentum is depend on the mass and the velocity of the body. How it is depend on the mass? Okay, so here once again I am going to show you these two objects are there. This is the lighter one and this is the heavier. This object is heavier than this cylindrical object. One is cuboidal shape and another one is cylindrical. So the cuboidal shape object is heavier than this cylindrical object. Okay, so mass is different. The mass of this cuboidal object is more than the cylindrical object. Now, how the momentum is depend on their masses, that I am going to explain. Suppose both the objects I will drop from this height, from some height I will drop, and both these objects will move down with the same velocity. The speed will be same. Okay, suppose this is the way I am going to explain. You can see here. This is the cylindrical object. And another one is this is the cuboidal object. Two objects I am having. A strength does not mean the body will be in the same shape. The shape of these bodies can be different. Okay, maybe spherical, maybe rectangular, maybe in a square shape or maybe in cube shape. So other shape also can be there. Okay, it does not mean the shape will be the same. So but I have two objects, so different shapes and different mass. So here this M, capital M, and this is small m, and the mass of this cuboid is greater than this cylinder. But one thing is common in both. They have been dropped from the same height. Both the objects have dropped with the same height and they will move downwards then they will move with the same height. I will drop these objects and they will move down with the same velocity, with the same speed. Okay, so here the speed of this object u, and this is also u. Okay, so can you guess which one object can hurt you more? Suppose you are sitting under this object and I will drop both the objects one by one with the same velocity, with the same speed. Then which object will hurt you maximum or more? The cuboidal, because this has maximum mass. This mass is more in comparison of this cylindrical object. So because of this mass, the momentum of this cuboidal object will be more than the momentum of this cylindrical object. Is it clear? Are you understanding? So that's why the momentum of the object is depend on their masses also. Okay, so the momentum, you understood? Then if the mass is lighter, then the momentum also will be less. If the mass will increase or mass is greater, then the momentum also will increase. Okay, so this is the one thing, that the momentum depend on the mass, and how it will depend on the velocity. Now second, I am going to explain how it depend on the velocity. Okay, so and I will explain the definition of the momentum also properly. So now I have taken this object only. This is the one of the single object, cuboid shape object I have. Okay, now from this height I am going to drop this one. Okay, now it is not going to hurt me. Okay, I am not going to hurt it, but momentum is there because it is coming down with some speed, with some velocity. Okay, but the mass is constant. Now the mass is constant for the same object. If we are taking 2 kg stone or 1 stone or iron piece, whatever we want, and we will take that object in any place. Okay, you can take this 2 kg object on the moon, on the Mars, on the Jupiter, on the Saturn. Okay, wherever you will take, the mass will be constant. Mass will not be changed. Okay, so this is 2 kg object. I am going to drop from here. It is not going to hurt me. Okay, speed is slow, mass is constant. But now if some same object I will drop from the roof of the building and I am standing downwards, down of the building, then what will happen? It will hurt me. It can injure me. What happened? Because mass, although mass is same, mass is not going to be changed. Mass is constant, but still the same object can hurt me. The same object can injure me. What happened now? What are the changes are there? The speed has been changed. What changes are there? The speed has been changed. So as the speed of this object will increase, I will drop it from the roof of the building, then it can hurt me. So the speed is changed, the momentum of the object also has been changed. So the momentum of the body depend on the 2 units. Number one mass, and number 2 velocity. If the speed will constant and the mass will increase, momentum will increase. Mass is constant, speed will increase, the momentum will increase. Okay. So now the proper definition of the momentum is product of mass and velocity. The momentum is the product of momentum of a body. Definition can be momentum of a moving body. It is must that object should be moved. Momentum of a moving body is the product of mass and velocity of the moving body. So the momentum of the body will be the product of the mass and the velocity of a moving object. Is that clear? The momentum is denoted with a small letter p. Okay, then what will be the formula? Momentum equals to mass into velocity. Momentum equals to mass into velocity. Okay, P equals to mv, where m is the mass of the object and v is the velocity of a moving body, and v is the velocity of a moving body. So this is the way that we can write down the definition and the formula of the momentum. Okay, this is the definition and the formula of the momentum. Momentum equals to mass into velocity. P equals to mv. Okay. Now, students, the momentum is a vector quantity. Momentum is a vector quantity. Why it is a vector quantity? I can explain you. See, when the object is coming downwards, direction, then what is there happening? The object have a direction also, magnitude as well as the direction. That's why the momentum in the object, that is vector quantity. Okay, and the SI unit of momentum is that is kilogram meter per second. Okay, kilogram meter per second. So now I can say that you understood the definition of the momentum. How can you explain this? How can you learn and what is the definition and dependency of the momentum on the mass and the velocity. Okay, students. And now the second law of Newton's second law of motion. I am going to explain the Newton's second law of motion, and after in the next video also I will explain some applications based on the momentum and Newton's second law of motion. Okay, so the Newton's second law of motion, I am going to explain Newton's second law of motion. Newton's second law of motion. It is also, this law also known as the law of momentum. This law also known as the law of momentum. Okay, so according to Newton's second law of motion, okay, according to Newton's second law of motion, student, force is directly proportional. Force is directly proportional to change in momentum per unit time. Change in momentum per unit time. Okay, what is the meaning of change in momentum? Momentum is going to be changed. It means the object is moving with a different speed. Okay, suppose the object is starting to move, object is moving with the initial velocity u. Object is moving with the initial velocity u. Okay, and mass of the object is m. Then what will be the initial momentum? Initial momentum, that we can take P1. P1 equals to mu. Okay, this is the initial momentum mu. I am going to explain this one. Okay, derivation also we can write down whole derivation. Here we can like this we can write down, let a body is a body of mass m is moving with initial velocity of u, and after t seconds it attains the velocity v. Then now because when object is moving with initial velocity u, then the initial momentum will be mass into velocity mu, and when velocity is going to be changed, then final velocity v, then final momentum will be mv. So here we can write down, we can go forward. Then force is represented by F equals to proportional to, here we can write down final momentum minus initial momentum upon time t. Final momentum minus initial momentum upon time t. Okay, so we can write down like this, and then change final momentum. What will be the final momentum, students? That the final momentum will be mv. Here F is proportional to mv minus initial mu upon t. Now m we are taking common, proportional mv minus u upon t, and this v minus u is change in velocity per unit time, and this is the definition of acceleration. So in place of this we can write down v minus u upon t equals to a, acceleration. Then it will be F proportional to ma. Okay, remove the proportional sign, equals to k ma. K is the constant, where k equals to 1, then F equals to ma. This is the Newton's second law of motion and the derivation. Students, watch the video, and if you are understanding or any doubt is, if you are understanding the concept, that is very good. If you are not understanding, you can WhatsApp me or drop the message. I will respond to you. Okay, God bless you, students, and thank you.